Hello class, this is a video tutorial on linear functions part 4. In this video we'll look at the equation of a line. In particular, we will look at calculating the actual equation of a line, and it goes as follows. If you are given the gradient of a line and any other point passing through that line, the equation of the line can be found using y minus y1 equals m bracket x minus x1. Okay, so I'm going to demonstrate to you this using two examples. Here we go. I'll copy this equation down so we don't need to scroll up and down for it. Here it is. So this is what we will be using. So notice how in this equation, this formula, we need a gradient. So first, we'd like to calculate the gradient between the line that, didn't draw that properly, the line that would pass through this point. Okay, so we need the gradient of this line, whatever it might be. Well, let's find the gradient. In case you've forgotten, it's y2 minus y1. So in this case, I'm going to go 10 minus y1 over x2, 8, minus x1. Evaluating this, we get 16 over 10. And this will give us, dividing everything by 2, 8 over 5. That is my gradient. And now I'm going to use this gradient for this formula to calculate the equation of this blue line that I've just drawn. For this, we need to pick any point that line passes through. So I'm just going to pick the positive points here. So using my gradient, m equals 8 over 5, and my point p, 8, 10, let's calculate the equation. So it is y minus y1. Here's my x1, y1, in case you're wondering. Y minus y1, 10, equals m, which is 8 over 5 brackets, x minus x1. X1 is now 8. Evaluating all of this, I'm going to do this in two ways. I'm going to do my preferred way first, showing this in the general form. I do not like the fraction. I'm going to multiply everything by 5. So we get 5y minus 50 equals 8 outside x minus 8. Expanding this group, we get 8x minus 64. Now, since 8x needs to be positive, I'm going to move this to the right hand side as well as the 5y. Okay, so nothing will be left on the left hand side. It'll be 8x minus 5y. Now it will be negative 64 plus 50. Negative 64 plus 50 is going to be negative 14. Just to clean this up, we have 8x minus 5y minus 14 equals 0. So this is the equation of the line using general form. Let's do one more example. So here's our equation again, in case we've forgotten. So once again, we need the we'd like to calculate the equation of the line passing through these 2 points. In case you can't visualize it, I will draw a quick sketch. This will look something like the following. Here's my point, negative 8, 2. And here's my point 4, 5, somewhere down over here. 4, negative 5. And we want the equation of the line passing through both of those. Now in order to do that, we will follow this equation once again. So first we need the gradient. Let's calculate the gradient between these 2 points. Let's let this one be x1, x2, oops, y1, x2, y2. M is equal to x2 minus, y2 minus y1, 2 minus -5 over x2, so -8 minus 4. This will give us 7 over 12. That is our gradient. And now for our point, we can pick either one of these. So I'll pick the one on the left since I've already labeled it x1, y1. So for this we need y minus y1. Well, y1 is -5 equals the gradient m, which is 7 over 12. X minus x1 is 4. For this one, I will demonstrate to you how to calculate this in the y-intercept form. So we get, let's evaluate each point. We get y plus 5 equals 7 on 12x minus, well, 7 times 4, -4 is -28 on 12. Moving this to the right hand side, we get y equals 7 on 12x minus, for this I'm just going to use my calculator, -28 on 12 minus 5. -22 on 3. In case you missed the reason for this, why I'm minusing 5, this +5 I'm moving to the right hand side. So this will give us -28 minus -28 on 12 minus 5 is -22 on 3. And that is the equation of the line passing through the points 4, -5, -8, and 2. So I hope that gave you an insight into the equation of the line, and hope to see you in the next video. Best of luck.